Hi guys, so let's go ahead and get started on this section 7 review. Now these first two questions are actually honors topic 1 questions which we actually covered in section 6. So they are review questions. The first one's asking us to factor the polynomial completely. Now remember, before you start using any method of factoring, we always want to factor out a GCF. So you could actually factor out 2 from all of these terms, which would give you x to the power of 4 plus 2x cubed plus 3x squared plus 4x plus 2. And then remember that if you have more than 4 terms, then you have to use P over Q's to find what are the possible rational zeros and then test those zeros out to see which one would actually be a factor. So remember that P's are the factors of the constant term. So the factors of 2 would just be 1 and 2. And then Q's are the factors of the leading coefficient. Now the leading coefficient in this case is 1. The only factor of 1 is 1. So P over Q, 1 divided by 1 is 1, and 2 divided by 1 is 2. So our possible rational zeros are just 1, -1, 2, or -2. Let's go ahead and start testing out. Let's see if 1 is a 0. So we're going to go ahead and write all of the coefficients. Now we've already factored out a little bit, so we're going to use what we have simplified here as a factor, which would be 1, 2, 3, 4, and 2 coefficients. Remember, if you have any zeros for placeholders, then missing terms, then you have to use a 0 for a placeholder. So bring down your first term. 1 times 1 is 1. Add, we get 3. 1 times 3 is 3. Add 6. 1 times 6 is 6, add is 10, 1 times 10 is 10, add we get 12. So we didn't get 0, so 1 is not a 0. Let's go ahead and try -1. So again, the coefficients are still the same because we haven't factored this anyway yet. So I'm going to go ahead and do this again. 1 times -1 is -1. Add, we get 1. 1 times -1 is -1. Add, we get 2. -1 times 2 is -2. Add, we get 2. -1 times 2 is -2. Add, we get 0. So awesome. -1 is a 0. If -1 is a 0, that means that x plus 1 had to have been a factor, right? So essentially what we did here is we divided by the factor of x plus 1. And the result that we got as a quotient was 1x cubed plus 1x squared plus 2x plus 2. Because remember, when you're doing synthetic division, your result is always 1 less than the power that you started. And then these are the coefficients to each term. Now, we have 4 terms here, and we could try to group to factor. If we group the first 2, right, we could factor out x squared, which gives us x plus 1. If we group the last 2, we could factor out a positive 2, which gives us x plus 1. So we can actually factor this 4-term polynomial right here by group to factoring. So I'm going to go ahead and just bring down the 2 and the x plus 1. And from these 2 terms, I could then factor out the x plus 1, which gives me then x squared plus 2. I'm going to go ahead and bring down this x plus 1 and bring down the 2. So x squared plus 2 cannot be factored any further. So the question was factor the trinomial, which we've already done. I'm just going to go ahead and rewrite it because we have 2 copies of x plus 1. So I could write it as x plus 1 squared, 2 copies of that. And then 1 copy of the x squared plus 2. Okie dokie. Moving on to number 2, they're asking us to find all of the zeros for this polynomial right here. So we have 4 terms, and remember, anytime we have 4 terms, we can try to group to factor. So grouping the first 2 plus grouping the last 2. If we factor out from the first 2 an x squared, we would get 2x minus 5. And if we factor out from the last 2 a -1, we get 2x minus 5. So we can actually group to factor here because when we group the first 2 and we group the last 2 and we factor it out as much as possible, these 2 binomials are the same, which means that I could factor out both of those binomials from both the first term which would then just leave me with x squared on that first term, and from the last term, which gives me -1 on the last term. Now, x squared minus 1 is actually the difference of squares, right? This is x squared minus 1 squared. So this actually factors further. So the full factored version of this is 2x minus 5 times x plus 1 times x minus 1, because that is the difference of squares. And so this is the factored version. However, they asked us to find all of the zeros. So to find the zeros, we set f of x to equal 0, and then we go ahead and solve for this equation. Now, since it is in factored form, we can use the zero product rule. Any one of these factors, if they equal 0, then the entire equation would equal 0, and that will give us a solution. So 2x minus 5 equals 0 gives us a solution of 5 over 2. X plus 1 equal to 0 gives us a solution -1, and x minus 1 equal to 0 gives us a solution of 1. So we had 3 zeros here. Remember that the amount of zeros that you should have is the degree of your polynomial. So the degree was 3, we had 3 zeros, we have all of them, and that is our final answer. All right, let's go ahead and move on to number 3. So on number 3, we need to simplify this rational expression. Now remember, to simplify, we want to use the method of factoring. We're going to factor the top, we're going to factor the bottom, and then we're going to cancel out any common factors. Now the numerator is a trinomial and the coefficient is 1, so we're looking for two numbers that multiply to -3 and add to -2, which would be -3 and 1. So the numerator factors into x plus 1 times x minus 3. The denominator is actually the difference of squares, right? X squared minus 1 squared. So this will factor into the difference of squares, which is x plus 1 times x minus 1. Now remember that anytime that you have any fraction with a variable in the denominator, you do have to write the excluded values. The x value cannot equal any value that will make the entire denominator 0. If I have -1 for x, that'll make this denominator 0. And then if I have 1 for x here, that'll make this factor 0, which will make the entire denominator 0. So x cannot be -1 or 1. Then I also want to go ahead and cancel out any common factors. X plus 1 divided by x plus 1 would cancel. And so my numerator is just the x minus 3, and the denominator is just x minus 1. So that is the entire rational expression simplified. Okay, let's move on to number 4. So we're finding the inverse here. And remember, to find the inverse, we could just simply switch the x and the y values. So if we switch this y value with x and then switch this x value with y, we can go ahead. Oop, I almost forgot this x value. There's an x value here as well, so I need to switch that with y as well. I could go ahead and solve for y. Now, in order to solve for y, I'm going to need to multiply 2y minus 3 on both sides just to get rid of the fraction. Once I distribute x, I get 2xy minus 3x. And on the right-hand side, I just have y. So I have multiple terms with the variable that I am solving for. Now, whenever I have multiple terms with the variable that I am solving for, I do need to bring all of the terms with the variable that I am solving for to the same side. So now I have -3x equals y minus 2xy. The reason why I want to bring all of the terms that have the variable that I'm solving for to the same side is because I can then consolidate and factor out that variable that I'm solving for. If I factor out y, I would get 1 minus 2x, which then means that I could simply divide by that 1 minus 2x on both sides to get y by itself. So the inverse would be -3x over 1 minus 2x. Now, of course, there is a variable in the denominator, so the denominator cannot equal 0. Now, if you can't see what the variable x is that would make the denominator 0, you can always write it as an equation, right? The denominator cannot equal 0, and then solve for the variable x like an equation. So if you subtract 1 and divide -2, you could see that x could not equal 1/2. So we have to write that as a part of our answer. So the inverse is -3x over 1 minus 2x, and x cannot equal 1/2. Alrighty. Let's go ahead and look at number 5. So we're going to go ahead and multiply these two expressions. And remember, with multiplying fractions, you just multiply top times top over bottom times bottom. So you're really just looking at numerator over denominator. Now we want to factor out any pieces that we can. So x squared minus 9 is actually the difference of squares, x squared minus 3 squared. So that'll factor into x plus 3 times x minus 3. And of course, times x is still there. In the denominator, x plus 3 can't be factored anymore. However, 2x minus 6, I could factor out 2 from x would be 2 from 2x would be x, and then 2 from negative 6 will give me negative 3. Remember, before you cancel anything out, we have to list our excluded values. The variable x cannot equal negative 3 because then that will make 0. 0 times anything is 0. And it cannot equal positive 3 because then that would make this 0, and 0 times anything is 0. Then we can go ahead and cancel out common factors. X plus 3 cancels, x minus 3 cancels. So we end up with x in the numerator, 2 in the denominator, and that is the simplest form. All right, let's move on to number 6. So on number 6, we want to go ahead and multiply these. So another multiplication question, again, top times top over bottom times bottom. So we're really just looking at one full fraction, and we just need to go ahead and factor the different pieces. X squared plus 4x plus 4 would factor, because this is a perfect square trinomial, would factor into x plus 2 times x plus 2, right? 2 times 2 is 4, 2 plus 2 is 4. And then x squared minus 2x, I could factor out x from both of those, which gives me x minus 2. On the denominator, x minus 5 can't be factored anymore. But x squared minus 4 is actually the difference of squares, is x squared minus 2 squared. So this is actually going to factor into x plus 2 times x minus 2. Before I keep going and canceling out any factors, I'm going to go ahead and write my excluded values. X cannot equal 5, or negative 2, or positive 2. Then if we cancel out common factors, x plus 2 divided by x plus 2 cancels, x minus 2 divided by x minus 2 cancels. So in the numerator, we have x times x plus 2, which would be x squared plus 2x. And in the denominator, we just have x minus 5. Okie dokie. Let's move on to number 7. On number 7, we need to divide these two expressions, and remember that dividing any number is the same as multiplying the reciprocal, right? So I'm going to go ahead and rewrite this as numerator and denominator of the first fraction, keep that, but then change the division to multiplication and flip the second fraction. Now that this is a multiplication problem, we can treat it like the last two that we just did, top times top over bottom times bottom. So you really just have one full fraction. Factor the different pieces. We could factor out x from both of these will give me x plus 4. Remember, factoring out is division, right? And then to factor this trinomial, we multiply to negative 2, add to negative 1, would be negative 1 and negative 2 and 1, because we have to add to negative 1. So x minus 2 times x plus 1. In the denominator, this trinomial would factor, multiplies to 8, adds to negative 6, would be 4 and 2. Specifically, we want the 4 and the 2 to both be negative. That way we add to a negative, but multiply to a positive. So this will factor into x minus 2 times x minus 4. And then lastly, I could factor out 3x squared from both of these. So if I factor out 3x squared, that will give me x plus 4. All right, before I continue, I need to go ahead and write my excluded values, right? X cannot equal 2, or 4, or 0, or negative 4. And then I can go ahead and cancel out any common factors. So I could cancel out one copy of x here with one copy of x here, still leaves one copy of x in the denominator. I could cancel out x plus 4 divided by x plus 4. And I can cancel out x minus 2 divided by x minus 2. So in the numerator, all I have is x plus 1. And in the denominator, I have 3x times x minus 4. 3x times x is 3x squared. 3x times negative 4 is negative 12x. So this is my simplified rational expression. And this is my excluded values. Okie dokie. Let's move on to number 8. So number 8 is a division question. This is a complex fraction, right? We have numerator divided by denominator. Remember that we want to go ahead and simplify the numerator and simplify the denominator into one fraction. However, in this case, the numerator is already one fraction and the denominator is already one fraction. So we can, in that case, just take your numerator and then divide the denominator simply by multiplying the reciprocal of the denominator. So 70x minus 60 over 7x squared plus 64x minus 60. Now multiplying, right? You just multiply top times top over bottom times bottom. So let's go ahead and factor the pieces. Factor out 2 from both of these, we get x minus 1. We can factor out 10 from both of these, we get 7x minus 6. In the denominator, right, this coefficient can be factored out from all 3 of these, so I could factor out 2 from all of them, which gives me x squared plus 5x minus 6. Then I could actually factor this further, because negative 6 multiplies to negative 6 adds to 5 would be 6 and negative 1. So this entire trinomial would factor into 2 times x plus 6 times x minus 1. Then the last one that I need to factor is this one right here. I cannot factor out 7 from all of them. So I'm just going to go ahead and actually write that work up here so that you could see how to factor this one. Now remember, when you do not have a coefficient that you could factor out and the coefficient is not 1 and you can't make it 1 like we did here, you do have to rainbow over. So we're looking for 2 numbers that multiply to 7 times negative 60. Okay, so let's find 7 times negative 60. Well, negative 7 times 60 is the same thing, which is negative 420, and we'll add to 64. So remember, when you're finding the 2 numbers and you can't like think of them right away, like who knows what things multiply to negative 420 and add to 64? Probably not off of the top of your head. You can try to divide. So negative 420 divided by 2, and then check, do 2 and negative 210 add to 64? No, right? So negative 420 divided by 3, so on and so forth. Now, if I continue to try, right, negative 420 divided by 4 and negative 105 don't add to 64. If I continue, you want to try sequentially, try 5, and then try 6. Once you finally try and get to 6, you see that 6 and negative 70 would add to 64, except it would add to negative 64, so we want to make the 6 be the negative and the 70 be the positive. That way we add to positive 64. Okay, so once you find those 2 numbers, that's what you want to split the middle term as. Instead of writing it as 64x, we want to write it as 70x plus negative 6x. And remember, the order that you write these do not matter. Then you group the first 2, you factor out as much as you can, which we could factor out 7x, gives us x plus 10. And then grouping the last 2, we could factor out as much as you can, which you could factor out negative 6, and that gives you x plus 10 as well. As long as you found the 2 numbers properly, these 2 binomials will always be the same. So you could factor then out that binomial. Gives you 7x on the first term, negative 6 on the second term. So this trinomial here factors into x plus 10 times 7x minus 6. Alrighty. So then from there, let's go ahead and write our excluded values, right? The denominator cannot equal 0, so none of these factors can be 0, because if not, then 0 times anything would make the entire denominator 0. So x cannot be -6, it cannot be 1, it cannot be -10, and it cannot be add 6 divide 7, 6/7. So then, let's go ahead and cancel out common factors. So x minus 1 divided by x minus 1 cancels, 2 divided by 2 cancels, 7x minus 6 divided by 7x minus 6 cancels, and that's it. Remember, you cannot cancel out terms. You can only cancel out full factors. So in the numerator, I have 10, and in the denominator, I have x plus 6 times x plus 10, which will multiply together is x squared plus 16x plus 60. And that is the simplified, fully simplified expression. All right, let's move on to number 9. Now on number 9, we have another complex fraction here. However, the numerator is not already simplified into one fraction, and the denominator is not already simplified into one fraction like we had on number 8. So what we need to do is we need to go ahead and consolidate the numerator to be one fraction. So we need to combine these two and actually subtract them. So remember, in order to subtract fractions, you do need a common denominator. So I'm going to multiply the factor of 5 that's missing on the first fraction and multiply the factor of x minus 5 that's missing on the second fraction. Once you get the denominators to be the same, they stay the same for your result. And then we can go ahead and combine the numerator. Do not forget that we need to distribute. So 5 times 3x is 15x, and negative x times x is negative x squared. Negative x times negative 5 would be positive 5x. So when I simplify the numerator, this entire numerator will be negative x squared plus 20x. In the denominator will be the 5 times x minus 5. I'm just going to go ahead and leave that in the factored form. Okay, now I need to go ahead and do the same thing with the denominator. I need to go ahead and figure out what is this denominator as one fraction. Oops, I wrote plus 5. I was going to write plus 5 when it's minus 5. So x minus 5 over 25 plus x over x minus 5. So again, same thing. We need common denominator in order to actually be able to combine those two fractions together. So I'm going to go ahead and multiply the first fraction by the x minus 5 factor that's missing on the denominator of the first fraction, and multiply the second fraction by the 25 that's missing on the second fraction. So now the denominator of both is 25 times x minus 5. Now that the denominator is the same, I could go ahead and group the top. And again, we need to distribute. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. And then over here on the right-hand side, positive x times 25 is 25x. If we go ahead and we simplify this top numerator, we get x squared. Minus 5x is minus 10x. Minus 10x plus 25x is 15x. And 25 is just 25. In the denominator, we have the 25 times x minus 5, which I'm going to just leave it in factored form. So now that we have one fraction in the numerator divided by one fraction in the denominator, we can go ahead and take the numerator and divide the denominator by multiplying the reciprocal of the denominator. Okay? And then once you do that, right, now we just have a multiplication problem. So we're going to do the same thing as before. Top times top, over bottom times bottom. So really you're just looking at a bunch of multiplying things here. So let's go ahead and factor this out. We could factor out negative x, which would give us, my pen wasn't working there for a second. Let's go ahead and erase that, negative x. And then negative x squared divided by negative x is positive x. 20x divided by negative x would be negative 20. Over here, that's already factored out. It's 25 times x minus 5. So I have negative x times x minus 20 times 25 times x minus 5 in the numerator. In the denominator, 5 and x minus 5 on the left side is already simplified there. Factored. I just need to go ahead and factor this trinomial. So x squared plus 15x would factor into, multiplies to 25, adds to 15. I'm just thinking, multiplies to 25, adds to 15. The only things that multiply to 25 would be 1, 25, and 5 and 5. So there is nothing. Okay, so this denominator is just going to stay like that. X squared plus 15x plus 25. So before I go ahead and I start canceling out any common factors, I have to list my excluded values, right? The denominator cannot equal 0. So no factors in the denominator can equal 0, which means that x cannot be 5. And this trinomial cannot equal 0 either, because if that's equal to 0, then 0 times all of this would give me 0 in the denominator. So in order to figure out what values will make this 0, I'll have to use the quadratic formula. So remember, the quadratic formula is negative b plus minus the square root of b squared. 15 squared is, I believe, 225. Let's check that. 15 squared is 225. Minus 4 times the a value 1 times the c value 25. I could actually do that right now. 4 times 1 times 25 will be negative 100. Then in the denominator, it will be 2 times a. A is 1, so it would just be 2. 225 minus 100 is 125. So this is the square root of 125 over 2. Now the square root of 125 can be simplified because 125 is 25 times 5. And the square root of 25 is 5. So the square root of 125 is 5 square root of 5. So the final simplified version here, let's go ahead and scroll down a little bit. The final simplified version would be negative 15 plus minus 5 square root of 5 over 2. So that's the value that x cannot equal, because this cannot equal 0, which means that x cannot equal this. And so x cannot equal 5, or negative 15 plus 5 square root of 5 over 2, or negative 15 minus 5 square root of 5 over 2. Now let's go ahead and cancel out common factors. X minus 5 cancels, and then 5 cancels out with one copy of 5 here. 25 is really 5 times 5, so we get a copy of 5 that remains in the numerator. So in the numerator, we have a negative 5x times x minus 20. Negative 5x times x is negative 5x squared. Negative 5x times negative 20 will be positive 100x. In the denominator, I just have this trinomial here, which is x squared plus 15x plus 25. All right. And that is the fully simplified version. Let's go ahead and move on to number 10. All right, so on number 10, we need to find the sum. Now remember, anytime that you are combining fractions, right, we need to make sure that we have a common denominator. So this denominator, I could try to factor it to see if I have a common factor, because yes, I could multiply by the entire denominator here and multiply by this entire denominator here. But if you actually factor this, right, multiplies to negative 21 adds to negative 4 is negative 7 and 3. So this actually factors into x minus 7 times x plus 3. So if you factor it, you actually see that this fraction does actually have an x plus 3 factor. So that means that I don't need to multiply this fraction by anything. All I need to do is multiply this fraction by the x minus 7. And then now both of the fractions have that common denominator. Now remember, once the common denominator is there, it stays the same for your result. So the denominator is x minus 7 times x plus 3. And then we could just go ahead and combine the top. Now on the top, I do need to simplify that because I will need to combine like terms. So x minus 7 times x plus 5 will multiply to x squared minus 2x minus 35, and then the plus negative 12x minus 4 will just be negative 12x minus 4. Now be careful, if this was subtraction, then you would need to distribute that negative to both. But it's a positive, so a positive times a negative is a negative, a positive times a negative is a negative. All right. Now at the top, we can actually combine, right? Negative 2x minus 2x to minus 12x, excuse me, is negative 14x. Negative 35 minus 4 is negative 39. The x squared is just x squared. And then I should try to factor this numerator to see if there's an x minus 7 factor or an x plus 3 factor. But the numbers that multiply to negative 39 would be negative 3 and 13, right? If we can use our calculator. 39 divided by, it doesn't divide by 2 obviously because it doesn't end in an even number. But 3 and 13, that would not add to negative 14, okay? And we actually have to subtract to negative 14 because we are multiplying to a negative. So one of them is going to be positive and one of them is going to be negative, right? And then 39 divided by 4 wouldn't work, 5 wouldn't work, 6 doesn't work, 7 wouldn't work, 8, 9, nothing else works. So this numerator actually cannot be factored into anything, so it will just stay like that. So for my final answer, I'm just going to go ahead and simplify this denominator by multiplying everything out. X times x is x squared. Negative 5x plus 3x will be negative 4x, and negative 7 times 3 is negative 21. Now, of course, I almost forgot. Let's go ahead and write our excluded values. X cannot equal 7 or negative 3. Okay? And again, that's because this numerator wasn't able to be factored to cancel out with anything in the denominator. So that's just the simplest form. Let's go ahead and move on to number 11. So we need to find the difference here. So again, we are combining. Anytime we're adding or subtracting fractions, we're really just combining and consolidating them into one. So I'm going to go ahead and factor this denominator. That's the difference of squares that factors into x plus 4 times x minus 4. So there's already an x minus 4 factor on both of these fractions. All I need to do is multiply by x plus 4 on the second fraction. So once I multiply both, the denominator is the same. So the denominator stays the same for my result. And then in the numerator, I have 3x plus 4. And then do not forget, this is a negative 2 that needs to be distributed to both. So negative 2x minus 8, because negative 2 times 4 is negative 8. Okay, let's simplify. 3x minus 2x is 1x, and 4 minus 8 is negative 4. All right, before I write the fully simplified version, I'm going to go ahead and write my excluded values. X cannot be either negative 4 or positive 4. So x cannot be plus or negative 4. And then I can go ahead and actually cancel out this entire denominator. X minus 4 will cancel out with x minus 4. So in the numerator, I really just have 1. And in the denominator, I have x plus 4. And that is the simplified version. All right, that's number 11. Let's move on to number 12. So on number 12, we're solving this equation, and remember that the strategy that we can use for solving equations, because as long as all of the denominators are the same, so let's say you had x over 2 equal to 5 over 2, right? If the denominator is the same, then you can multiply that denominator, whatever it is, on both sides and cancel it on every single fraction. So that is only possible if you have an equation, that way you can multiply that denominator to both sides, and that all of the terms in the equation have that common denominator. So we're going to use that strategy. This denominator is n plus 5, this denominator is n minus 5, and this denominator is n squared minus 25, which actually factors into n plus 5 times n minus 5. So if I multiply n plus 5 on this fraction, and then I multiply n minus 5 on this fraction, then I have n plus 5 times n minus 5 on every single denominator. So essentially, if I multiply both sides of the equation by that denominator, it'll cancel it on every term. So that will give me n times n minus 5, which would be n squared minus 5n, plus 5 times n minus 5, which would be 5n plus 25, equal to 2n plus 24. Then from there, I could bring over both of these terms by subtracting them on both sides. And that'll give me equals 0. Then if I simplify the left-hand side, n squared plus 5n minus 5n cancels, so that's just negative 2n, and 25 minus 24 is 1. I get a quadratic. I could also factor that quadratic. It would factor into n minus 1 times n minus 1, since negative 1 times negative 1 is 1, negative 1 plus negative 1 is negative 2. I get the solution of n equals 1. Now remember, you always have to check your excluded values. The excluded values are the values that cannot that make the denominator 0, because the denominator cannot equal 0. So n cannot be either 5 or negative 5. Now, if we check our answer, 1 is not one of those excluded values, so 1 is a valid solution. All right. Let's move on to number 13. So we have another solving example here. So we have the factor of r squared minus 18r plus 8. Now, if I factor that, that would actually factor into r minus 8 times r minus 10. Negative 10 times negative 8 is 80. Negative 8 plus negative 10 is negative 18. And of course, that is the same factorization, since this is the same exact trinomial here. R minus 8 times r minus 10. Now, these two fractions have that same denominator. This fraction has an r minus 8, but is missing an r minus 10 factor. So I need to multiply that on this one. Now every single denominator has that factor. So if I multiply by r minus 10 times r minus 8 on both sides, it would cancel out all of those denominators, leaving me with r minus 10 plus 1 equal to 10. Now, of course, remember your excluded values you do have to keep in mind. When we are solving this, r cannot equal 10 and r cannot equal 8. So if I get that answer when I solve here, that would be an extraneous solution, okay? Now, I'm going to go ahead and continue solving this. Negative 10 plus 1 would be negative 9. And then to solve for r, I would add 9 on both sides. So I get the solution of r equals 19. Now, if we check that with the excluded values, 19 is not 10 or 8, so this is a valid solution. Okay, let's move on to number 14. So number 14, let's go ahead and do the same thing. We're going to use the strategy of getting all the denominators to be the same in the equation. That way we can cancel them out. So we can go ahead and factor out n here. Will give us n minus 7. So we can see here that we have the factor of n minus 7 on all of them, but we're missing the factor of n on this fraction and this fraction. So I'm going to go ahead and multiply n on top and bottom for this fraction and multiply n on top and bottom for this fraction. Now every single denominator is that n times n minus 7. So if I were to multiply that on both sides, they would all cancel. Now, remember, you still have to keep in mind with your excluded values, right? N cannot equal 0, n cannot equal 7. Now, we're going to go ahead and solve. We canceled out the denominators by making them all equal. So we get 5n plus 30 minus 2n times n, which would be negative 2n squared, equals 1 times n, which is n. I subtract n to get equal 0. Of course, if I do that to one side, I have to do it to the other. I have the negative 2n squared I can bring down. 5n minus 1n is 4n, and 30 is just 30. We can try to factor this to go ahead and solve it. We can factor out negative 2 from every single term, which gives us n squared minus 2n minus 15. Then the coefficient is 1, multiplies to negative 15, adds to negative 2, would be negative 5 and 3. So this would factor into n minus 5 times n plus 3. So when we solve, we get two solutions, n equals 5 and n equals negative 3. Now those two could be valid or they both could be extraneous. Let's go ahead and check them. N equals 5 is not an excluded value. Negative 3 is not an excluded value. So both of these are valid solutions. All right, let's move on to number 15. So on number 15, we have a boat travels at a constant rate of 3 miles per hour, and that's in still water. In a river with an unknown current, so the current speed is what I'm going to try to solve for. Let's call that x. It will take the boat twice as long to travel 60 miles upstream as it takes to travel 60 miles on the return trip. So of course, if you go 60 miles there to come back, on the return trip is also going to be 60 miles. Remember, for these word problems, we want to organize the information, okay? We usually have two things happening at once, right? So in this case, we are going upstream and we are going downstream. So I'm going to organize the information for up here, and I'm going to organize the information for downstream here. We have the distance, we have the rate, and we have the time. The relationship was made with the time. They told us that it takes the boat twice as long to travel upstream than it takes to travel downstream. So that means that if the time to travel downstream, let's call that TD, then the time to travel upstream is 2 times that TD. So in other words, the time to travel upstream is 2 times the time to travel downstream. Now the rate, right, is 3 miles per hour is the still water rate. If you're going upstream, you're going against the current. So the current is hurting your speed. So whatever the current speed is subtracted from the still speed. So your still speed minus your current speed would be the speed that you're traveling up. Now, when you're traveling downstream, the current is actually helping you to go faster. So whatever the rate you would take in still water, you add the rate of the current because the current is helping you to go faster. So instead of just going 3 miles per hour, which is the rate of still speed, you have that 3 plus that rate of the current that is helping you to go faster. Now the distance, right, we did say that up and down, both on the way there and the return, was 60 miles. Now remember that the relationship, right, distance is rate multiplied by time. Distance equals rate multiplied by time. So that means that the time is distance divided by rate. We need that because we need to go ahead and write what is the time upstream and what is the time downstream. Well, the time upstream would be the distance upstream divided by the rate upstream. So in other words, the time upstream would be 60 over 3 minus x. And then we want to do the same thing for time downstream, right? The time downstream would be the distance downstream divided by the rate downstream. So in other words, the time downstream would be the distance downstream, 60, over the rate downstream, which would be 3 plus x. And then we have an equation that we can solve. Now we can solve for x. Once we solve for x, that'll give us what we're looking for, which is the speed of the current. So let's go ahead and do that. 2 times 60 will be 120. So we have 120 over 3 plus x on the right-hand side. On the left-hand side, 60 over 3 minus x. You don't simplify that. Now we have one fraction equal to one fraction, so we have a proportion. We can go ahead and cross multiply, right? So 60 times 3 plus x equals 120 times 3 minus x. Now 60 times 3 is 180. 60 times x is positive 60x. 120 times 3 is 360. 120 times negative x is negative 120x. Now to solve, we're going to go ahead and add 120x to both sides to bring the variable on the left-hand side. And then we're going to subtract 180 on both sides to bring the constant to the right-hand side. 60 plus 120 is 180x, and 360 minus 180 is 180. To solve for x, divide 180 on both sides, and we get an x of 1. Now, of course, this is a real-world problem, so we need to put it into context. One what? One potato, one tomato, one classroom pencil? I don't know. So in this case, x represents the current speed, right? So this is that means that the speed of the current is 1. And then in the problem, right, we are using the unit of measure of miles per hour. So the rate of the current, the speed of the current is 1 miles per hour. All right, let's go ahead and move on to number 16. So on number 16, it says it takes Lita 7 more hours to paint a kitchen than it takes Hank to complete the same job. Together, they can complete the same job in 12 hours. How long does it take Hank to complete the job if he works alone? Okay, so Lita takes 7 more hours to paint the kitchen. And it takes Hank, oh, that's the question, actually. Excuse me. How long does it take Hank is the question. So we don't know how long it takes Hank. So Lita's time is 7 hours more than Hank's. So if we say that Hank's time, which is what we don't know, Hank's time, let's just call that H. Then Lita's time, because it takes her 7 more hours, is Hank's time plus 7 more hours. Okay. Now together they complete that job in 12 hours, right? So Lita, how much she completes per hour will be 1 over H plus 7. Hank, how much he completes per hour will be 1 over H. And their total time that it takes them to do it together is 12. So the 1 over H plus 7 plus the 1 over H would equal 1 over 12. So now we just need to solve this equation. And once we solve for H, that'll give us Hank's time, which is what we are looking for if he were to do it alone. So in order to solve this, I'm going to need to combine and consolidate these two fractions right here, right? So I'm going to go ahead and multiply this fraction by H on top and bottom, and multiply this fraction by H plus 7 on top and bottom. Now I could get all the denominators to be the same and then cancel them all out, but I don't want to have to multiply by 12 as well. So I'm just going to leave it like that and consolidate these two fractions on the left together. So now we have the common denominator of H times H plus 7, and then numerator 1 times H is H, 1 times H plus 7 is H plus 7. Then on the right-hand side, of course, we have 1 over 12. Now that we have a proportion, 1 fraction equal to 1 fraction, I can go ahead and cross multiply. So H plus H is 2H, so we have 2H plus 7 that I need to multiply by 12. 2H times 12 is 24H, 7 times 12 is 7 times 12, 84. Yes. And then 1 times h plus 7. Of course, h times h plus 7 is h squared plus 7h. So 1 times that would just be h squared plus 7h. Then we need to solve, right? We need to solve for h. So I'm going to go ahead, and this is a quadratic. I'm going to bring over the 24h, and I'm going to bring over the 84. So I'm going to subtract 24h and subtract 84 to both sides. So now I have h squared, and then 7h minus 24 is negative 17h, and I'm going to bring down the negative 84. So now in order to solve this, I could try to factor to solve, right? Multiplies to negative 84. Adds to negative 17. Let's test out some things. I'm not sure. 84 divided by 2 is 42, so that's not going to work. 84 divided by 3 is 28. That's not going to work. 84 divided by 4, 21. Yes, that works. So we want to add to a negative, so we want the 21 to be the negative and the 4 to be positive. Negative 21 plus 4 will be negative 17. Since the coefficient is 1, this is easy factoring. This will factor into h minus 21 times h plus 4. Okay, so we get two solutions, h equals 21 and h equals negative 4. Now h represents Hank's time. He cannot take a negative amount of time to do this kitchen painting project. So that solution gets tossed out, which means that Hanks takes 21 hours to complete the job. Okay. Now, if the question was how long does it take Lita, then Lita's time is just 7 more than that. So Lita's time will be 28 hours. But it asks for Hank's time. H represents Hank's time. So that's just 21 hours. All right. Let's go ahead and do number 17. So working together, Jenny and Natalie can mop a warehouse in 5.14 hours. Has she done it alone? I think that meant had. It's a typo. Had she done it alone, it would have taken Natalie 12 hours. How long would it take Jenny to do it alone? Okay, so Jenny's time, we'll call that J. Natalie's time is 12. Actually, let's just call Jenny's time X. Whatever. It's a different variable. It means the same thing. And then together, they take 5.14 hours. So how much time it takes Jenny per hour will be 1 over X. And then on Natalie's time, right, per hour is 1/12. And together, they get that done in 5.14 hours. So when I solve for X, I will have solved for Jenny's time, which is what we're looking for. So let's go ahead and get these denominators to be the same to group these two fractions. I'm going to multiply by 12 on this fraction, multiply by x on this fraction. That way the denominator of both is 12x. 12 times 1 is 12. 1 times x is x. So this is 12 plus x. On the right-hand side, I have 1 over 5.14. And now that I have a proportion, one fraction equal to one fraction, I could go ahead and cross multiply. So 12 plus x times the 5.14 equals 1 times 12x, which would just be 12x. 5.14 times 12 is 61.68. And 5.14 times x, which of course will be 5.14x. I'm going to go ahead and bring all of my x's to the right-hand side by going and subtracting 5.14 on both sides, 5.14x on both sides, and 12 minus 5.4 is 6.6. Ooh, 5.14. Whoopsie. 12 minus 5.14 is 6.86, excuse me. On the left-hand side, I'm going to go ahead and bring down the 61.68. And then to solve for x, we're going to divide by 6.86 on both sides. Let me make sure I get these numbers right. We have 61.86 divided by 6.86. And we get about 8.99. Okay, so it's like almost 9. So we could just go ahead and round that up to 9. So it's about 9 hours. Okay, so it takes Jenny about 9 hours to complete the job alone. Alrighty. Let's go ahead and move on to number 18. So a small jet has an air speed, which is the rate of still air of 300 miles per hour. And during one day's flight, the pilot noted that the plane could fly 85 miles with a tailwind in the same time that it took to fly 65 miles against that wind. Okay, so we have here two ways that you're going through, right? You're going there and then you're going back. So you have, let's see, there we go. Distance, rate, time. You have going with the wind, going on the way there, and then on the way back against that wind. Now, when you're going with the wind, right, you're going 85 miles. So you went with the tailwind and you went 85 miles. When you went against that wind, you went 65 miles. So we're organizing the distance there. And then the rate, remember, when you're going with the wind, that would help you to go faster, right? So the rate in still air is 300. So the rate when you're going with the wind would be the rate in still air plus whatever that rate of the wind is. Let's call the rate of the wind x, so plus x. When you're going against it, it's the opposite. When you're going against the wind, it's hurting you and it's making you go slower. So the rate going against the wind would be the rate of still air, and then subtract that wind speed that's hurting you to go slower. Then what is the relationship of the time? They told you that the pilot noted that it took them the same time to go 85 miles one way than it took to go back 65 miles the other way. So the time to go with and the time to go against, they said in the problem, based on the rest of it, is equal. So the equation is the time to go with is equal to the time to go against. So what is time, right? Remember, time is distance over rate, since distance equals rate multiplied by time. So the time to go with would be the distance with divided by the rate with. So it would be 85 over 300 plus x. And then the time against would be the distance against divided by the rate against. So the time against would be the distance 65 over the rate 300 minus x. Now this is a proportion, right? One fraction equal to one fraction. So we could go ahead and cross multiply. 85 times 300x equals 30 plus x times 65. So 85 times 300 minus x equals 65 times 300 plus x. Let's go ahead and distribute. 85 times 300 is 25,500. And of course, 85 times negative x is negative 85x. 65 times 300. Oops. Let's clear that. I think I put too many. 65 times 300 is 19,500. And then 65 times x is 65x. Okay. I'm going to go ahead and bring this over here, but before I do that, I'm going to add 85x to both sides to bring the variable to the right. and subtract 19,500 on both sides to bring the variable to the left. Now, 25,500 minus 19,500 is 6,000. And 65x plus 85x is 150x. Then to solve for x, divide 150 on both sides. 6,000 divided by 150 is 40. So x is 40. X represents the rate of the wind, so that means the rate of the wind is 40, and the unit of measure here is miles per hour. All right, let's go ahead and move on to number 19. All right, f of x and g of x, find the x value of the point where f of x equals g of x. So we're just finding the x value. We don't have to find the y value that matches. But we are figuring out the solution to the system. So what we can do is we can go ahead and set these two equations equal to each other. We can set the two functions equal to each other, and that'll be where they intersect. Let's go ahead and cross multiply since this is a proportion. -2 times x plus 3 equals 4 times x plus 4. Distribute -2, we get -2x minus 6. Distributing 4, we get 4x plus 16. Then to solve, we're going to add 2x on both sides to bring the variable to the right. Subtract 16 on both sides to bring the variable to the left. -6 minus 16 is -32. No, 22. I think so. I think 22. Let's check. Yeah, 22. And 4x plus 2x is 6x. Divide by 6 on both sides, we get x equals -22 over 6. And if we simplify that, and remember they're only asking for the x value in this case, if we simplify, divide by 2 on top and bottom, we get -11 over 3. Okay, and they only asked me for the x value, so I'm not going to solve and plug in to find the y value because they only asked me for the x value. Let's go ahead and move on to number 20. Very similar question, but in this case, they are asking me for the entire point of intersection. So I'm going to check where m of g equals b of g, and I need that entire ordered pair point that they intersect. So I'm going to go ahead and cross multiply, right? G plus 4 times G minus 8 equals G minus 2 times G minus 5. So let's go ahead and distribute and distribute. We would get G squared. 4 times -8 is -32. And 4g minus 8g would be -4g. On the right-hand side, distribute, distribute. G times g is g squared. -2 times -5 is +10. -2g minus 5g would be -7g. Now this is going to be a quadratic, or what looks like to be a quadratic. So I think I'm going to move everything over to the left-hand side. I'm going to go ahead and subtract g squared on both sides. Add 7g on both sides, and subtract 10 on both sides. Now when I do that, I actually cancel out g squared on both, so this is not going to be a quadratic, which is great. -4g plus 7g is 3g. -32 minus 10 is -42. And on the right-hand side, I canceled everything out, so we just have 0. Now I need to add 42 because this is actually a linear, to bring that to the right-hand side, and then divide by 3 on both sides, we get g equals 14. 42 divided by 3 is 14. So now we have the input of the ordered pair is 14. We need to plug that input in to find the output. You could either plug it into m or to b. It doesn't matter. Okay, so I'm going to go ahead and plug it into m. m of 14 would be 14 plus 4 over 14 minus 2. Now 14 plus 4 is 18, and 14 minus 2 is 12. 18 over 12 would simplify if I divide by 6 on top and bottom. 18 divided by 6 is 3. 12 divided by 6 is 2. So we simplify to 3 over 2. So input 14, output 3 over 2. All right, let's move on to 21. So which function matches the graph? Ooh, okay. Well, let's take a look here, because remember that the vertical asymptote, right, is whatever makes the denominator 0 and doesn't cancel. So the vertical asymptote in this question is the line x equals 5. So which denominator would give me an undefined value of x equals 5? A or B, right? So automatically we can go ahead and cancel out C and D because those would not be the correct vertical asymptotes. Now let's go ahead and do the same thing of trying to cancel out and see which solutions would be correct by looking at the horizontal asymptote. If you look at horizontal asymptote, right, the horizontal asymptote is the line x equals 1. Or, I'm sorry, it's a horizontal line, so it would be the line y equals 1. Whoopsie. And remember that the horizontal asymptote will be a number if the numerator and denominator degree is the same. Now, unfortunately for us, the numerator and denominator degrees are the same for both of these, and both of them would, if you divide 1 divided by 1, 1 divided by 1 is 1 on both. So both of these have a horizontal asymptote of y equals 1, so that doesn't help me narrow it down. The next thing I could do is try to find x-intercept or y-intercept. So you could see here that there's an x-intercept of 1. So I could try to find that x-intercept, and remember the x-intercept is whatever will make the numerator 0. Because the x-intercept has a y value of 0, so if I were to plug in a y value of 0 here, right, and I multiply the denominator, I will get 0 equals x minus 1. If I were to plug in 0 here and I multiply the denominator, I will get 0 equals x minus 4. So here I get a x-intercept of 1, and here I get an x-intercept of 4. So which one is the correct x-intercept? A. So A is my answer, B is incorrect. Okay, your answer would be A. All right, let's move on to 22. On 22 through 27, we're going to identify all of these key features. Points of discontinuity, which remember are vertical asymptotes and holes. Vertical asymptotes are the not removable ones, and holes are the removable ones. We're going to find the x and y intercepts and the horizontal or oblique asymptotes. So let's go through. Let's start with points of discontinuity. To find points of discontinuity, we want to go ahead and factor the denominator, because the points of discontinuity are the points that cannot be found where the x value does not exist, which would be what makes the denominator 0. So if we factor the denominator, right, multiplies to negative 15, adds to negative 2, would be 3 and 5. So that would be negative 5 and positive 3. That way we actually multiply to a, or add to a negative number. So this would be x minus 5 times x plus 3. And from there, you could see that the values that are excluded that are going to make the denominator 0 would be 5 and negative 3. Now, if in the numerator we could factor that and cancel something, then that would have been a whole. Because there are no cancelable factors, there are no holes. The vertical asymptotes, there are 2 of them. The line, vertical line x equals 5, and the line, vertical line x equals negative 3. The next thing we want to go ahead is to find the intercepts. So let's go ahead and find the x-intercept and the y-intercept. To find the x-intercept, we're going to go ahead and set the y value to equal 0. And when you multiply the denominator, it'll cancel out the denominator anyway. And on the left-hand side, 0 times anything is 0. So really the x-intercept is just what's going to make the numerator 0. So if we add 7 and divide 3, we see that that x-intercept is 7 over 3. Next up, let's go ahead and find the y-intercept. For the y-intercept, I'm going to set x to be 0. So when we zero out all of these numbers, right, 3 times 0 is 0, minus 7, and then in the denominator, 0 squared minus 2 times 0 is 0, minus 15. So it's really just the constants divided by each other. So negative 7 divided by negative 15 would be positive 7 over 15. So the y-intercept is 7 over 15. And then let's go ahead and figure out, is there a horizontal asymptote? Remember, there can only be an oblique, which is also called a slant, if there is no horizontal asymptote. Now, the horizontal asymptote, there are 3 cases, right? Your numerator degree is bigger than your denominator degree. Your numerator degree is equal to your denominator degree, or your numerator degree is less than your denominator degree. If they are equal, then the line for the horizontal asymptote will be y equals whatever the coefficient of the numerator is divided by the coefficient of the denominator. If the numerator is bigger than the denominator, then there's no horizontal asymptote. And if the numerator is smaller, then the horizontal asymptote is just the line y equals 0. So if we compare the numerator degree, the degree is 1. If you go and look at the denominator degree, the degree is 2. So the numerator degree is smaller, which means that the horizontal asymptote is the line y equals 0. And that means that there is no slant, okay? Or if you want to call that oblique, whatever you want to call that. So that is all of the things that they asked us to find. And we are all done with number 22. Let's move on to number 25. On 25, again, you always want to start out with simplifying. Factor the top, factor the bottom. So if we factor out an x from everything, we're going to get x squared plus x minus 12. And then we can actually factor this because multiplies to negative 12 adds to 1 would be 4 and negative 3. So the numerator will factor into x times x minus 4. Plus 4 times x minus 3, because we want to add to a positive 1. In the denominator, I could factor out negative 3x, and that gives me x plus 1. Now, if you simplify this, right, you could see that a factor of x is going to cancel. A factor of x is going to cancel on the top and the bottom. That is something that would have made the denominator 0 before, right? So that is a removable value. That is a removable point of discontinuity. So that is the x value to my whole. Now remember, to find the y value of the whole, you're going to use the simplified form. So if we just write this as the simplified form, after canceling out x, right, we would have x plus 4 on the top. I'm going to leave it in factored form just because it's easier to plug in numbers later, times negative 3, x plus 1. So you want to use the simplified form. Let's go ahead and plug in x is 0 into the simplified form. 0 plus 4 is 4. 0 minus 3 is negative 3. Negative 3, and then 0 plus 1 is 1. 4 times negative 3 is negative 12. Negative 3 times 1 is negative 3. Negative 12 divided by negative 3 is 4. So that is the y value to our whole. Then we also have the vertical asymptote. The vertical asymptote is any point of discontinuity, any value that's going to make the denominator 0, that stays. That is not removable, right? So the 0 of 0, which is going to, undefined because x cannot equal 0. It's an excluded value, right? The x value cannot equal 0 for the function. That was removable. X plus 1 is not removable. So your not removable points of discontinuity are your vertical asymptote. So in this case, we just have 1, which would be the x value of negative 1. So the vertical asymptote will be the line x equals negative 1. Okay, let's move on to finding the x-intercept. For the x-intercept, we can go ahead and plug in y is 0. And if we plug in y is 0, remember, when you multiply the denominator, it'll cancel out, and 0 times anything is 0. So the x-intercept is just what's going to make the numerator 0, which would be the values of negative 4 and 3. So we have two x-intercepts. One's at negative 4, and the other one is at 3. Next, let's go ahead and find the y-intercept. Now the y-intercept is found by setting x to be 0, right? So imagine if we zeroed out these values, right? We would end up with 0 divided by 0. And you can't divide by 0 in the denominator, right? Because if you divide by 0, you get an error. You can't make, groups of nothing. You can't take something and make groups of nothing. So that tells us that there is no y-intercept. There is a y-intercept, right? But it is actually the whole, which is why there is no y-intercept. Like the whole is an empty open circle. So that point doesn't exist on the function. So there is no y-intercept here. Okay, let's move on to finding the horizontal asymptote. So for the horizontal asymptote, let's go ahead and compare the degree on the top with the degree on the bottom. Notice that the degree of the numerator is bigger than the degree of the denominator, so there is no horizontal asymptote here. So if there's no horizontal asymptote, that means that a slant may exist. And a slant exists if the numerator degree is bigger than the denominator degree by 1, which is the case here. We find the slant by dividing. So I'm going to go ahead and divide my numerator by my denominator. And I would have to multiply negative 3x squared by negative 1/3 x to get x cubed. Oop, I almost forgot to put the 0 placeholder. There's no constant. So you could also find that by dividing, right? 1x cubed divided by negative 3x squared is negative 1/3 x. Now, negative 1/3 x times negative 3x squared will be 1x cubed, and negative 1/3 x times negative 3x will be positive 1x squared. Then when we subtract these two, anything minus itself is 0, so this is 0x squared, and I'm going to bring down negative 12x. Then I'm going to ask myself that question again. What do I multiply negative 3x squared by to get 0x squared? Or you can divide 0x squared divided by negative 3x squared will be 0. So you have a 0 for a constant. Then when you multiply, obviously you will get 0x squared plus 0x. And when you subtract, you will get some x value. You would bring down, this is 0, but there's nothing else that you multiply. So you are done with the division. And when you do that, when you end up subtracting and getting the remainder, remember that you disregard the remainder. So I don't need to continue with the slant. With the division, you only have to go as far as your linear term and your constant term. Because remember, the slant is going to be a line. So all you need is that slope and the y-intercept. The rest of it is going to be the remainder, which if you were dividing and finding what is this divided by this, then you would need that remainder. But in this case, for the slant, you disregard the rest of it. All you need is that slope, and then the constant tells you the y-intercept. Because there is no y-intercept, that is just the line. It's the line y equals negative 1/3 x. All right, let's move on to number 23. So on 23, let's go ahead and do the same thing. We're going to go ahead and factor the top. We can factor out negative x squared, which factors, then this leaves x minus 1. And on the bottom, we can factor out an x from everything, which gives us x squared minus 4x plus 3, and then multiplies to 3, adds to negative 4, would be negative 3 times negative 1, negative 3 plus negative 1. So the bottom factors like this. Now, notice that we have two values that cancel, a copy of x and the x minus 1. So that means that there are two wholes here. We have one whole which has an x value of 1, and another whole which has an x value of 0. So let's go ahead and write the simplified form here so we could find those values. So now we have negative x, actually that canceled, so just negative x in the numerator, and in the denominator we just have x minus 3. So if we plug in f of 1, that would give us negative 1 over 1 minus 3, which would be negative 1 over negative 2, which would be 1/2. So for the x value of 1, that y value is 1/2. Then we can go ahead and plug in 0. F of 0 would be negative 0 divided by 0 minus 3, which would be 0 divided by negative 3, which is 0. So for an x value of 0, the y value is 0. Then we can go ahead and find the vertical asymptote. Remember that the vertical asymptote is any point of discontinuity that didn't cancel. So that would be for x value of 3. So it will be the vertical line x equals 3. Then we can go ahead and find our y-intercept and our x-intercept, but both of these are going to be none. Now, we can go ahead and plug in 0, what makes the numerator 0, but notice that this is a hole, right? So if we have a hole at 0 for x and at 0 for y, that means that both the x-intercept and the y-intercept will be an open point there, which isn't actually a point on the graph. So both of these would be none. Then we can move on and find the horizontal asymptote, or to find if we have a horizontal asymptote. And we do that by comparing the power, the degree on top and the degree on bottom. If the degree is equal, remember that the horizontal asymptote is the line y equals the coefficient of the top divided by the coefficient of the bottom. So y equals negative 1 divided by 1, which would be negative 1. If there is a horizontal asymptote, that means that there is no slant. And we are done. All right, let's move on to 26. So on 26, I'm going to go ahead and simplify again. So f of x equals numerator, which is x minus 5, denominator would factor. Multiplies to 3, adds to 4 will be 3 and 1. So it will multiply x plus 3 times x plus 1. Now, there are no points of discontinuity in the denominator that cancel, so there are no holes. The vertical asymptote, there are 2 of them because both of these do not cancel, so both of them are not removable. One is at x equals negative 3, and the other one is at for the line x equals negative 1. Then we can go ahead and find the x-intercept. Remember that the x-intercept is any value that's going to make the numerator 0, because when you multiply by the denominator, 0 times the denominator would just be 0. So it'll be for x value of 5. And for the y-intercept, that is any value which will make x 0. So what y value will make the x value 0? So if you zero out, 0 minus 5 is negative 5. 0 plus 3 is 3, and 0 plus 1 is 1. So it will be negative 5 over 3. Next up, let's go ahead and find any horizontal asymptote. If we look, coefficient on top, coefficient on bottom, or excuse me, degree on top, degree on bottom. The degree is bigger on the bottom, right? The numerator degree is smaller than the denominator degree, which means that our horizontal asymptote is just the line y equals 0. And if there is a horizontal asymptote, that means that there is no slant. So that is number 26. All right, let's move on. So number 24, same thing. Number 27, same thing. We're just finding the key features. Let's go ahead and simplify on top, simplify on bottom. So for this one, the numerator is just x cubed. The denominator, I need to go ahead and factor this one. Now I want to rainbow over, multiplies to negative 12, adds to negative 1, will be negative 4 and 3. If I split up negative 4 and 3, it would end up factoring out 2x in the front. So if you do all the work, this bottom denominator will factor into 2x plus 3 times x minus 2. You can always kind of work backwards of using the FOIL method, right? 2x times negative 2 will be negative 4, and then 3 times x will be 3x. Those added together will give me negative x. 3 times negative 2 will give me negative 6. Now, if you notice, none of those cancel, so there are no holes. And both of these denominators are remaining, which means that there are 2 vertical asymptotes. One's at x equals negative 3 over 2. The other one's at x equals positive 2. For our y-intercept, we can go ahead and set x to be 0. If we set x to be 0, it would zero out the numerator. So we have 0 over 0 minus 6, which would be 0 divided by negative 6, which would be 0. Now, there are no holes, so that is just our y-intercept is 0, which means that our x-intercept is also 0, and you could also tell that because if we set the y value to equal 0 and we multiply the denominator, which cancels, what makes x cubed 0? Well, 0. Then we can go ahead and find the horizontal asymptote. Remember, you want to compare the degree on the top with the degree on the bottom. If the degree is bigger on the top, like it is here, that means that there is no horizontal asymptote. Now, the degree is bigger on the top by 1, so there is a slant. And the way that we find the equation of the slant is we divide. We want to divide x cubed by our denominator, which is 2x squared minus x minus 6. Now, remember, we need zeros for placeholders, so I'm going to go ahead and put in a 0 for the quadratic term, the linear term, and the constant term. Then we can go ahead and divide, right? X cubed divided by 2x squared would be 1/2 x. Multiply 1/2 x times 2x squared will be x cubed. 1/2 x times negative 1x will be negative 1/2 x squared. And 1/2 x times negative 6 will be negative 3x. Then we go ahead and subtract these two. Anything minus itself is nothing. 0 minus negative 1/2 will be positive 1/2 x squared. 0 minus negative 3 will be positive 3x. And we can go ahead and bring down the 0. Then we want to go ahead and do this again, right? What times 2 would get me 1/2, right? Or 1/2 divided by 2, which would be 1/4. So 1/4 times 2 will be that 1/2 x squared that I'm looking for. 1/2 times negative x will be negative 1/4 x. 1/4 times negative 6 will be negative 6 over 4. Now, when I subtract this, I'm going to get some remainder, but remember, the remainder cancels, so you really didn't even need to do this step either. All you need to do is make sure you get the correct, linear term and the correct constant term, because that will be the line for your slant. So the line for the slant is 1/2 x plus 1/4. Okay, and let's go ahead and move on to number 27. Last one. So let's go ahead and factor the top. We can factor out 2x. That gives us x plus 1. Factor the denominator. The denominator will factor, multiplies to negative 2, adds to 1, will be positive 2 and negative 1. So the denominator will multiply x plus 2 times x minus 1. So there are no canceling out points of discontinuity, right? Undefined values. So there are no holes. There are 2 points of discontinuity that are remaining, not HAVA. So the vertical asymptote are going to be 2 lines, the line x equals negative 2 and the line x equals 1. Next up, for our y-intercept, we're going to go ahead and set the x value to be 0, right? So 2 times 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 minus 1 is negative 1. So we have 0 times 1, which is 0, over 2 times negative 1, which is negative 2. 0 divided by negative 2 is 0. So the y-intercept is 0. The x-intercept is any values that will make the numerator 0. If 0 is a y-intercept, it's automatically going to be an x-intercept, but you're going to see that when we solve anyway. So if we set 0 equal to the rational simplified expression here, and we multiply the denominator, it will cancel it out. So it's really what's just going to make the numerator 0. So we can see here the numerator x being 0 will make the numerator 0, and x being negative 1 will also make the numerator 0. So we knew that 0 was an x-intercept based on that it was a y-intercept, but we have another x-intercept of negative 1. Lastly, let's go ahead and see, is there a horizontal asymptote? In this case, yes, there is, because the numerator and denominator degrees are equal. And remember, if the numerator and denominator's degrees are equal, the horizontal asymptote will be the line y equals coefficient on top, 2 divided by coefficient on bottom, 1. 2 divided by 1 is 2, so the horizontal asymptote is the line y equals 2. Slant, in this case, there is none because there is a horizontal asymptote. Remember, a horizontal asymptote, if a horizontal asymptote exists, a slant does not. All right, let's move on to the last few questions, which are on graphing. So in order to graph, remember, we want to find all of the key features, and then we want to find any maybe points to make sure that we're graphing the correct part of the graph. So let's go ahead and find the key features. So we have -1 over, the denominator will factor into x plus 3 times x minus 3. That tells me that we have two vertical asymptotes. One is at x equals 3 and one is at x equals -3. There are no holes here because we do not have any cancelable points of discontinuity. Then we can go ahead and find the horizontal asymptote, which in this case, remember, if the degree is bigger on bottom, which this constant has a degree of 0, right? So the degree is bigger on bottom, the horizontal asymptote is y equals 0. Next, let's go ahead and find the x-intercept, which are any values that are going to make the numerator 0, which are none. And then the y-intercept, in this case, would be any value that makes x 0, any y value that makes x 0. So this will be -1 over 0 minus 9. So we have -1 over -9, which would be 1/9. Now I'm going to estimate that value, that 1/9, so that I can plot it. It's about 0.1. So let me go ahead and graph my vertical asymptote. X equals -3. And x equals +3. Let me graph my horizontal asymptote, which is y equals 0, the x-axis. And then let me go ahead and figure out which part should be graphed in which piece. Now the y-intercept is a +0.1, so that tells me that this middle piece is going to be infinitely trying to reach the trying to touch the asymptotes on the top, okay? Remember, each vertical asymptote separates your graph into pieces. So you have the left piece. Is that graphed on top or is that graphed on bottom is what we need to find. The middle piece, is that graphed on top or is that graphed on bottom? We already know because of the y-intercept is graphed on top. And then the right side, right, is that graphed on top or is it graphed on bottom? That's what we need to find. Now we don't know that based on the key features, so that means that we need to plug in some random x value and find a y value. Now obviously you don't want it to be that random, you need it to be some x value that's here, so that way you know, is it on the top or is it on the bottom? Where does that point lie? So I need to pick an x value that will be in this area, in this graphing area here. So I'm just going to go ahead and go with -4. So I'm going to plug in -4 into my function, right? So what is f of -4? That will be -1 divided by -4 squared minus 9. Now -4 squared is 16, right? So that'll be 16 minus 9. Let me bring up a calculator here. -1 over 16 minus 9. So I could actually just type it all into the calculator, -1 over 16 minus 9. And you're going to get a fraction. You can click the estimation arrows to get an estimated value. So it's about -0.1. The whole point is to see where is that point, right? So for an x value of -4, the y value is -0.1, which tells me that it's not graphed on the top because the y value wasn't positive. The y value is negative. So this point is going to be on the bottom, which tells me that this graph will be graphed on the bottom on this left side. Now we need to do the same thing on the right side. Where is it graphed? Is it graphed on the top or is it graphed on the bottom? So we need to pick an x value here. Let's go ahead and pick +4 but you have to pick an x value that's in this area. If you pick like 2, for example, 2 is not on that right area. An x value of 2 is in the middle area. So we want to pick an x value that's in the right area. So that will be an x value of 4, or you could use 5, 6, anything else. Now, if we plug in 4, 4 squared will also be 16. So you could see that this is also going to give me negative 0.1. So this is also graphed on the bottom. So that is what the graph will look like. Let's go ahead and do number 29 next. So for 29, let's go ahead and find all the key features, right? I'm going to go ahead and factor the top, factor the bottom. That's the difference of squares, just like the previous problem. So that'll graph into x plus 3 times x minus 3. The denominator is x plus 2. And there are no removable points of discontinuity. You can't cancel out any factors, so no holes. The vertical asymptote would be that value that is undefined, which would be an x value of negative 2. So the vertical asymptote will be at the x value of negative 2. So vertical line at x equals negative 2. Let's go ahead and graph that right now. Then let's go ahead and find the horizontal asymptote, if there is one. And we're going to look at the degree on top with the degree on bottom. Notice the degree on top is 2, the degree on bottom is 1. So if the degree is bigger on top, there's actually no horizontal asymptote, and the degree is bigger on top by 1, so there is a slant. Let's go ahead and find the slant by dividing. Okay, remember you have to put any 0 for placeholders, so there is no linear term here, so I need to put a 0x. And we are dividing by x plus 2. Actually, this is dividing by something that we could use synthetic division for, because the coefficient is 1 and the power is 1. So we could actually just use synthetic. 1, 0, negative 9 are my coefficients. The 0 would be negative 2. If we bring down 1 times negative 2 is negative 2. Add, we get negative 2. Multiply, we get positive 4. Add, there's some number, but remember you disregard the remainder. So the slant will be the line y equals 1x minus 2. So that is the slant. I could graph that slant, right? I could graph the slant using the y-intercept, negative 2, and then the slope is rise 1 over 1. So I could go ahead and graph that slant. There you go. And then I'm going to go ahead and find my x and y intercepts, right? That'll tell me which pieces I need to graph. So my x-intercept, I'm going to set the y value to equal 0. Remember, that's just what's going to make the numerator 0. So the numerator will be 0 at a negative 3 and at positive 3. So those are our two x-intercepts, negative 3 and positive 3. With those x-intercepts, I actually already know which pieces to graph, but let's just go ahead and find the y-intercepts just for, for everything to be complete. So the y-intercept will be when x is 0, so it's just a division of the constants. Negative 9 divided by 2, which is negative 4.5. So if I graph that, negative 4.5. Okay, now remember, each vertical asymptote splits your graph, right? So you have the left side and you have the right side. You can only graph either on top or on bottom of your horizontal asymptote or oblique. You cannot graph on both sides. So that tells me that if I have an x-intercept here, the left side will be graphed on the top of this oblique, not on the bottom, not here, okay? The vertical, the x-intercept, excuse me, tells me that this is going to be graphed on the top of the oblique, okay? Now, I'm having a little trouble curving this graph, but it's close enough, okay? And then on the right side, again, the x-intercept and y-intercept told me that this is actually graphed on the bottom, right? It's not going to be graphed on the top, right? Because the x-intercept was not here. So if there are points on the bottom half of the oblique on the right side, then that is graphed on the bottom on the right side, okay? Getting close to the asymptotes. Okie dokie. Let's go ahead and move on to the last two problems. So number 30, we have sketching this function right here. Let's go ahead and simplify it. On the top, this would factor into x minus 2 times x plus 1. On the bottom, this would factor into x plus 4 times x minus 2. So we have a whole, okay, because the point of discontinuity, x minus 2, is removable. So that means that the whole is at x value of 2. And then to find the y value, we're going to use the simplified version of the function and plug in that x value of 2. 2 plus 1 over 2 plus 4, 2 plus 4, would be 3 over 6, which is 1/2. So the whole, we can plot that with an open circle, is at 2 and 1/2. So it's right here. All right, let's continue. And the vertical asymptote, there's only one vertical asymptote in this case, and it's the value that makes the not removable discontinuity 0, which will be -4. So it's line x equals -4. Then we can move on and find the horizontal asymptote. And remember, we check the degree. Degree on top, degree on bottom. If the degree is the same, then the horizontal asymptote is line y equals coefficient on top divided by coefficient on bottom. 1 divided by 1 is 1. So the horizontal asymptote is at the line y equals 1. And I could go ahead and plot my vertical asymptote as well. It was the line x equals -4. Okay. So now we can go ahead and take a look at the x and y intercepts, okay? My x-intercept is setting the y value to equal 0. Remember, that will be any value that makes the numerator 0. So that would be an x value of -1. Yes, x value of 2 will make the numerator 0 as well, but remember that is a whole, right? So you want to use the simplified version. And then for the y-intercept, we set the x value to be 0, but that will just zero out all of these terms right here as well. So it would just be 1 over 4, which is 1/4, which is 0.25. So let me go ahead and graph my x-intercept of -1 and my y-intercept of 0.25. So that tells me that on the right side, right, I am graphing this on the bottom of the horizontal asymptote. Now the question is, on the left side, where is that graphed? Is it graphed on the top here, or is it graphed on the bottom here? So that is the question. Now the only way to find that out is to plug in some x value, okay? Some random x value, and then plug it in and find the y value that matches. Now, when you plug in that x value, you want to make sure that you're plugging in something that is in this area, right? So let's go ahead and plug in, let's just plug in -5. So if we plug in -5 plus 1 over -5 plus 4 will be -4 over -1. -4 divided by -1 is +4, so that means for an x value of -5, the y value is +4. So the point of -5, 1, 2, 3, 4, is on this function, which means that I am graphing on the top of the horizontal asymptote on the left-hand side. All right, last question, number 31. Okay, nothing to simplify on this one, so that's great. There are no removable points of discontinuity, so no holes. And the vertical asymptote is the value that makes the denominator 0 that is not removed. So that will be -2. So the vertical asymptote will be at the line x equals -2. Let's go ahead and find the horizontal asymptote. And remember, for the horizontal asymptote, you want to figure out what is going to be the degree on the top and what is the degree on the bottom. Now, a constant has a degree of 0, right? So the degree on the top is smaller than the degree on the bottom. And if the degree on the top is smaller than the degree on the bottom, then the horizontal asymptote is the line y equals 0. Remember, if there's a horizontal asymptote, there is no slant, so you don't have to worry about that. Then for our x-intercept is any x value that's going to make the numerator 0. Now, 5 can never be 0. There's no variable that will make 5 equal to 0, so that means that there is no x-intercept. The y-intercept is setting x to be 0. What is the y value? Which will be the division of the constants. 5 divided by 2, which is 5 over 2, which is 2.5. So let's go ahead and graph what we have, okay? Our vertical asymptote, x equals -2. Our horizontal asymptote, y equals 0. And we have a y-intercept of 2.5. Now that y-intercept tells me that on the right-hand side, right, this is going to be graphed on the top of the horizontal asymptote. The question is, on the left-hand side, is that going to be graphed on the top? Or is that going to be graphed on the bottom? So let's go ahead and plug in some x value into the function to find the y value that matches. Now, we don't want to pick any x value, right? Like if we pick 10, we're going to get a positive number. I know that because this graph is graphed on the top on the right-hand side. I want to pick an x value that's in this area. So let's go ahead and go with -3, okay? Plug in -3. So f of -3 would be 5 divided by -3 plus 2, which will be 5 divided by -1, which will be -5. So for an x value of -3, we get a y value that is negative. 1, 2, 3, 4, 5. So that tells me that on the left side, this is going to be graphed on the bottom of the horizontal asymptote. And that is the final question. All right, guys, I hope that that was helpful, and I will see you guys in another video. Bye.